What is inverse variation? Inverse variation is a relationship between two variables where one increases as the other decreases. Now let's solve this question and see how it works. The first thing that we are going to do here is to show the symbolic representation of this question. We have x varies inversely as the square root of y. In direct variation, if we are given this type of question, we will have x varies directly as square root of y, but here it is inverse, and I want you to know that this square root of y is the same thing as y square root of y over 1, because it is whole number, and every whole number can be written as fraction by writing them over 1. So you have this over 1, and if we are to write the inverse of this, it means the opposite. We are going to have 1 over square root of y, and this is what we have here. So the next thing that we are going to do here is to introduce our constant k and change the variation sign to equality sign. Why are we introducing our constant k? To show the rate at which they are proportional. You have x is equals to k times 1 over square root of y, and we have x is equals to k over square root of y. Now, if you notice, we are given these first two expressions. Why are we given the first two expressions? For us to know the rate at which they are proportional. So we are going to substitute the value, the first value that we are given, that is 2 and 225, into this equation for us to know the rate at which they are proportional. And I also want you to know that this x is equals to k over square root of y is an equation, and it's also the formula connecting x and y. We have 2 is equals to k over square root of 225. 2 is equals to k over square root of 225 is 15. So we are going to write this over 1 and cross multiply. We have k is equals to 2 times 15, and our k is equals to 30. Now we found the value of k. The next thing is to substitute it into our formula. X is equals to 30 over square root of y. So this is the equation connecting both variables, that is x and y. Now let's proceed. We are told to find the value of x when y is equals to 144. We are going to make use of this equation to find the value. We are told to find x when y is equals to 144. That is, where you have y, substitute 144 there. We have x is equals to 30 over square root of 144. We have x is equals to 30 over 12. Square root of 144 is 12. X is equals to 30 over 12. 2 can go here in 15 times, and 2 here you have 6. 3 here we have 2. 3 here we have 5. So our x is equals to 5 over 2. This is improper fraction, so let's change it to mixed fraction. We have our x is equals to 2 whole number 1 over 2. Let's solve the second question. Write down the equation connecting s and d. So let's write down the equation connecting s and d. We have s s varies inversely as the square of d. Let's introduce our constant k. We have s is equals to k times 1 over d square. S is equals to k over d square. Next thing, calculate the constant of variation if s is equals to 2 and d is equals to 5. Now let's substitute the first two expressions into our equation so that we can calculate the rate at which they are proportional. We have s 2 is equals to k over 5 square. 2 is equals to k over 25. This is over 1, cross multiply. We have k is equals to 25 times 2. Our k is equals to 50. Now let's substitute the value of constant into our equation. We have s is equals to 50 over d square. Let's proceed. Number 3, calculate the value of s when d is equals to 4. Let's find x when d is equals to 4. We have s is equals to 50 over 4 square. S is equals to 50 over 16. Let's break them into simpler units. We have s is equals to 50 over 16. 2 here 8, 2 here 25. There's no factor that can go in 25 that will also go in 8. So we are going to have s is equals to 25 over 8. So let's change it to mixed fraction. S is equals to 3 whole number 1 over 8. Let's find d when s is equals to 2.5. We are still going to make use of our formula. S is equals to 50 over d square. S is equals to 2.5. We have 2.5 is equals to 50 over d square. This is over 1. Cross multiply. You have 2.5 times d square is equals to 50 times 1 will give us 50. So we are looking for d square. Let's divide both sides by 2.5. 2.5. This will cancel this. Our d square is equals to 50 over 2.5. Our d square is equals to 50 divided by 2.5. You can do this in two ways. You can express this as a fraction. You have 50 divided by 25 over 10. So you inverse it. Inverse the second fraction. You have 50 times 10 over 25. 25 here 1, 25 here 2. You have 2 times 10. Our d square is equals to 20. It means 2.5 in 50 will give us 20. Now we are looking for d and not the d square. You want to cancel the square that you have here. So if you are cancelling square, you cancel square with square root. And the same thing is applicable to when you are cancelling square root. You cancel square root with square. D square times 1 over 2 is equals to 20 raised to power 1 over 2. This cancel this. You have d is equals to square root of 20. D is equals to 4.47. So we can approximate it to 1 decimal place. You have d is equals to 4.5. It's your turn. Solve this question and drop your answer in the comment section. Do not forget to like, share and follow for more mathematics interactive lessons.